voltage, power, and current, and you might remember this animation. One problem with this animation is that the voltage source shown was an AC source, while the current flow was shown as DC. So let's talk about the difference between AC and DC. The letters DC stand for direct current, and it generally means the electrons flow in a single direction. AC stands for alternating current, and it means that the flow of electrons change. Now this is where things can start to get a little confusing. This is an AC voltage source, so it's both AC and voltage. What the heck? How can voltage and current be the same? Well, it turns out we tend to use AC and DC abbreviations for voltage as well as current. So in other words, AC, voltage or current, is voltage or current that changes. DC, voltage or current, is voltage or current that is steady. Okay, so let's take a little bit closer look at these two, starting with DC. Check out this AA or LR6 battery. It provides 1.5 volts. This example circuit is going to be a DC motor like you might find in a toy car. When we insert the battery into the circuit, current begins to flow in a single direction, turning the motor. If we drew a graph where the vertical axis is voltage and the horizontal axis is time, we can see that the voltage at this point stays constant. Now, since this is a battery, eventually it's going to run out of energy and its output voltage will drop. So we know that the voltage will change over time, but the polarity will stay the same. So what is polarity? Well, polarity defines the positive direction, and for a battery, the positive voltage is created from the positive terminal. So what would happen if we turn this battery around? Well, that reverses the polarity, which means the current will flow in the opposite direction as before, causing our motor to spin in the opposite direction. Okay, so let's move on to AC, and in this case we're going to use a light bulb and a North American AC socket because, well, I live in North America. Notice how the circuit behaves when we turn the switch on. Let's break down what we're seeing by using the voltage graph again. Notice how the current is flowing in one direction, and as voltage increases, the light bulb gets brighter. Once the voltage reaches its peak, current flow stays the same, but the voltage begins to drop and the light bulb gets dimmer. Once we reach 0 volts, the voltage's polarity changes, causing current to flow in the opposite direction. And again, as the voltage gets closer to its peak, the bulb gets brighter and then dims back down. Okay, we need to define a couple of things. First is, the change from start to finish is called a cycle. The rate at which the cycle repeats is frequency. Now, frequency is measured using the unit hertz, which means cycles per second. Different parts of the world use different frequencies for their AC systems, and it can either be 50 or 60 hertz. What this means is in 1 second, the cycle will repeat itself at least 50 times. Believe it or not, incandescent bulbs are actually flashing over 50 times per second. Now, it turns out that this rate is so fast that our slow human eyes sees it as constant light. In summary, while the abbreviations for AC and DC include the word current, they can be used to describe different types of voltage and current. DC voltages do not fluctuate, while DC current flows in one direction. AC voltages change over time, and the current flow can alternate direction. If you have questions about this video, please feel free to leave comments below.